This is lecture Cam 4 of the Cam 810S course. The topic of this lecture is CNC lathe machine automation. Let us start with the clamping device. In this case, a collet chuck. Since long bars must pass to the spindle, the automatic clamping must be of the so-called hollow chuck type. Its components are the main pulley, which drives the spindle, a clamping cylinder, which may be pneumatic or hydraulic, sensors, one for the signal chuck open and one for the signal chuck closed, a clamping device, here a collet chuck, and a drawbar which is operated by the clamping cylinder. When the drawbar moves to the left, the chuck opens. When it moves to the right, the chuck closes. Concept Turn 250 is equipped with a pneumatic hollow clamping device and with a 3-jaw chuck and a programmable pneumatic operated tailstock for long parts. Tools are stored in a tool turret, often called also tool revolver. This tool turret holds 5 outside turning and 5 boring tools. Some CNC lathes are designed for turning and milling operations. In this case, we need a tool turret which can hold turning as well as milling tools. Milling tools must be power-driven. This is an example of a CNC lathe on which a milling operation is done, probably slot milling. CNC lathe with power-driven tools must be equipped with a programmable Z-axis, which can be indexed around the Z-axis, which is the main axis of a CNC lathe machine. Some CNC lathes are equipped with automatic tool measure devices, which facilitate the setup of the tools considerably. CNC lathes may be combined with bar feeders. To the right, we've got the CNC lathe machine, to the left, the bar feeder. Bar feeders feed the material automatically to the machine. Bar feeders provide a large autonomy to the work cell. Parts which are produced on CNC machines equipped with bar feeders are usually cut off with a parting tool after machining. They fall into the parts catcher tray, position 1, which is then emptied to the parts collection tray, position 3, from where it can be collected by hand. Parts may also be loaded and unloaded with robots, in this case a VAA or vertical articulated robot arm, as is the case in our FMS at the laboratory. Large parts are often handled by so-called gantry or Cartesian robots. This cell has quite a big autonomy. The conveyors to the left supply raw material, it may be the red colored ones, and finished parts, it may be the yellow colored ones. To the right side of the machine, we see a chip remover, which removes the chips from the machine. This is how a chip remover looks. There is a conveyor which moves the chips into a chip trolley. Now this is an FMS, a flexible manufacturing system which combines several CNC machines, loading and unloading devices, and material transfer systems. Flexible manufacturing systems are usually employed for the confection of medium batches of parts of the same part family. In this case, shafts for gear transmissions of various sizes and various complexity. For the car industry, for instance. Such a complex manufacturing system may run with relatively few but highly qualified technicians. One at the master control station in the left lower corner, one or two maintenance technicians, a team of repair specialists who care for several such units in case of a bigger disturbance, and a set-up team who sets the machines up for new tasks. This graphic shows the relation between batch size vertically, quantity of parts per year horizontally, both logarithmically, and the degree of automation on the right side. Exercise 4 shows the same graphic. After printing it, discuss it and draw your own conclusions. This is the end of the fourth CAM 810 lecture. Thank you for your attention.